Hi, myself Venkatesh. Today, let us look into an important topic, WPF controls. Before that, let us look into the WPF class hierarchy. High level, we will look into it, not briefly. As a .NET developer, WPF is built on layered architecture that integrates managed and unmanaged code. The hierarchy starts from the most fundamental .NET base classes and builds up to specialized UI elements. So let us look from bottom to top. Here you find that control is a base class for framework element. Framework element is a base class for UI element. UI element is a base class for visual element. Going top, the final so object.base class is a base class for all .NET types. As you know that as a .NET developer who has done .NET C# coding or VB.NET coding, they will be aware that all classes are derived from ob system.object. What that means? Let us take an example. Public class bank account. It's an empty class. I'm creating an instance of that class. So bank account B equal to new bank account. So B dot most of the people will think it will throw an error. It will not throw an error because B dot there are three methods exposed. One is toString equals and get hash code. Without if you see that bank account is an empty class, but when you put an instance of B, you find these three methods. This is because all .NET types are derived from system.object. That is why you are able to see these three methods. So in simple, every class in WPF inherits from this base class system.object. Let us look into the dispatcher object. WPF is a STA, single threaded apartment. So it is that with only one thread WPF runs. So in order to use multiple threads, you must write code via dispatcher object. Let us look later on how it works. This is nothing but thread affinity for WPF object. And also dispatcher object are accessed only from the thread they were created on. So using the dispatcher, you will be managing a thread safe operations. For example, in my business logic, I'll be having some data. I want to update this data in the UI. So this must be dispatched to the UI using the dispatcher.invoke. Let us look into another important object, dependency object. This supports dependency properties for data binding and styling. This is very important in WPF where 90% of the work you'll be working on this data binding. So what it means is that dependency properties which allow dynamic value resolution like enables features like data binding, animation and styles and many more. For example, I'm having a text box. So I'm having a text property and is dependent on the property. So this property will be communicating with the data source. So based on the data binding in the UI, you will get this. For example, textbox.text property is a dependency property that can be bound to a data source. Going for further videos, I'll just take a separate topic regarding dependency object, which is very huge and many more features and properties, everything, why it is static, why and more. This can be discussed in a separate video. Next, let's look into the visuals. So, in order to learn about visual, let us learn about logical tree and visual tree. So, in WPF, logical tree represents the essential structure of the UI and it closely matches the elements you declare in XAML. So, the important point here I want to know is that the logical tree, for example, window. So, window is a parent and the child is a stack panel. Under stack panel, I am having two buttons. So this is the logical tree. So in simple, logical tree does not include inner controls of the UI elements. And let us look into the visual tree. The visual tree represents all elements in your controls or in your UI. All logical elements including all visual elements of the template of each element. Let us take an example. Parent is window. I'm having a border, and next I'm having a stack panel. So button, in the inside stack panel I'm having two buttons. So the button will be having content presenter, text block, background, everything, and many more properties. So the inner elements also are available for visual tree. So in interview point of view, they will be asking like what is the difference between logical tree and visual tree. For this, this is the answer. The next is the UI element. Its role is it's nothing but interactivity and layout capabilities. That is, it supports input events like mouse, keyboard, focus, and layout. Here it introduces routed events and commanding. In this video only I can explain about routed events and commanding. Commanding will be I'll be teaching in the later section where it requires a lot of understanding. So in this section I will just uh, teach you about the routed events. The routed events should somehow travel up and down the tree. This means what? So here in WPF routed events are divided into three. One is via tunneling, bubbling, and direct. I'll explain about the tunneling event. Tunneling event which are first raised on the root and then on each element down the tree. I'll give an example so you can understand easily. For example, I'm having a preview mouse down or preview mouse up. So in that case, I'm having window, so panel and rectangle. So as a definition, the events which are first raised on the root here is window, and then it goes to the next element that is panel, and then finally to the rectangle. So the definition clearly tells that events which are first raised on the root and then on each element down the tree. So when I do preview mouse down or preview mouse up, first it goes to the window will tell okay, mm, go to the panel and then rectangle. So whenever in the rectangle you do some preview or do, it will have any other some other events. Let us go to the bubbling event. Events is first raised on the source element, and so bubbling events is first raised on the source element and then on each element up the tree until the root is reached. Suppose I'm having a mouse down or mouse up or click event. So what happens? I'm having a rectangle, panel and window. So whenever I do a click event in the rectangle and the parent is panel, it the source element is rectangle, and then it will go to the next element panel, and then it will route to the window. So here you find that it is first raised on the rectangle. This means that suppose I'm having a color, I want to show two types of color, brown, red. So whenever there is a click event, I want to show blue. Whenever I want to again, if I click, it should show. So it is routed to in this order. And finally is the direct event. Event is raised only on the source element. This means that whenever I enter a mouse, first time it will raise what it requires based on the business requirement, it will give the output. So the source, it will be the source element, and there'll be only one time it will have, one time it will be raised. So these are very important topic in routed events. So in interview also they can ask like what are routed events in WPF. So you can give with an example. And the next one is the framework element, which already discussed in the earlier video also. This is very important for data binding, styling and templating. Based on that, we can expose the API by sizing and positioning like height, width, horizontal element, vertical margin, padding. So all the layout properties we can handle. And the last one is the controls. So base class for all interactive UI control is control. So let us look about control in the next video. In the previous slide, I explained about the routed events in WPF. Here in the picture, you find the arrows for pre-mouse down, which is a tunneling event, mouse down is a bubbling event, and mouse event is a direct event. In the next slide, you find the Visual Studio Code with the XAML and business logic. In the previous slides, we just explained about the routed events. Let us now see the code and the XAML part and the business logic. Let me explain about the code walkthrough of routed events with respect to code. Here in the previous slide, we explained about the tunneling, bubbling, and direct. Here for this example, uh, the root is the window, and the next element is the stack and the ellipse, and based on that, the events are routed as you see in the code. So tunneling events are first raised on the root and then on each element. So here the root is the window element where we have provided a message box. Whenever it enters, whenever you click the mouse down or preview the mouse down, you find this message popping up. Similarly, for bubbling event, whenever the window is mouse down, you'll find this message popping up. And whenever you enter the ellipse, you find the direct event popping up. This is how it works, and it will be very useful in large projects where we use triggers as styles and with respect to the requirement. Thank you. Let us look into the WPF controller class hierarchy. At the top of our hierarchy is framework element. This is the base class for most UI elements in WPF. It provides essential layout, styling, and data binding capabilities. Uh, the derived classes are content presenter and controls. Content presenter, one of the direct children of framework element, is content presenter. It is lightweight element used to display content with templates, especially in control like button or list box item. Next we have controls branch. This includes all interactive UI elements. Controls are further divided into two categories: content control and items control. Under content control, we have label button and toggle button. So label displays static text, button triggers actions when clicked, toggle button maintains a state, checked or unchecked. Next, under controls we have item control, combo box, list box. So items control is used to display collection of items. It supports data binding and item templates. Examples include combo box and list box. And the combo box a drop down list with selectable items, and list box a scrollable list of selected items. So this is the hierarchy of the controls. Next, look into the panel and shape. So base class for panel is the framework element. Under that, the panel branch includes layout containers that arrange child elements. Each panel has unique layout behavior. Let us look into panel. The base class is framework element. Already in the previous video we have a brief description about panels, and as a short let us discuss once again. Canvas, absolute positioning, stack panel, elements vertically and horizontally, grid, arrange elements in rows and columns, wrap panel, elements to the next line when the space runs out, dock panel, align element to edges. Let's look into the shape. Base class is framework element. The shape branch includes graphical elements used for drawing. Let us see an example of ellipse and rectangle. So ellipse draws a circle or oval based on the width and height. Path draws complex shapes using geometry. Line draws a straight line. Rectangle draws a rectangle or square, depends upon the width and height. As we have discussed the important control class hierarchy, we have other controls like button, range controls, header content control, and items control. Let us discuss about the framework element. It is a base class for all UI elements that participate in layout, input, and rendering. Control adds support for templating and styling. It is base for all interactive UI elements. Content control allows a single piece of content, text, image to be hosted inside the control. ButtonBase is an abstract class that defines common behavior for all buttons like controls. It handles click events and command binding. If anyone in the interview asks about abstract class, you can mention ButtonBase in an example and you can see the metadata of my Visual Studio. Let us look into the derived classes. Button, RepeatButton, and ToggleButton are derived classes for ButtonBase. Button standard clickable. It triggers an action when clicked. RepeatButton fires the click event repeatedly while the button is pressed. ToggleButton maintains a state checked and unchecked, and RadioButton allows selection from a group of mutually exclusive options. As other controls like header content control, items control, and range controls, you can uh, look into it yourself. Thank you. I also like to give a tip or an interview question here. What is the conceptual difference between controls and primitive elements? Primitive elements is that controls do not have appearance. Primitive elements, not all elements are controls. What do you mean by that? Primitive, for example, text blocks, image, border, ellipse, everything are primitive elements where they don't have templates, they don't have content control. So there are primitive elements. And control implies behavior. Controls only have templates to replace its appearance. For example, a button can be in any form, rectangle, ellipse, square, everything, but a text block can't have. So that is the difference between both controls and primitive elements. It's an important interview question. And the other one is what is the difference between label and text block? As I told, text block is not a control. Even though text block lives in the system.windows.controls namespace, it is not a control. It is derived directly from framework element. Label, on the other hand, derived from content control, as you've seen in the class hierarchy. This means that label can be given a custom control template where we can use via template property. For display a string, we can use content property. We can apply data template to use content via content template property. Do whatever else a content control can do that a framework element cannot. And label text is grayed out when disabled. Label support access key. Label is much heavier than text block. So text block is lightweight. So these are some of the important questions you need to know when working on WPF. Thank you.